All right, good morning, and today we are going to talk about how we can prove that triangles are similar. So we have three different ways. If you look here, the first one, side-side-side similarity theorem. This is when we can prove that three of the sides are proportional. Okay, so last semester you learned about side-side-side congruence theorem. That was when we showed they were congruent, the triangles. Now the sides don't have to be the same, but they have to be proportional. Okay. The second one here, side angle side similarity theorem. That's when there's two sides on either side of this angle that is marked congruent are proportional. And then finally, the angle-angle similarity postulate. If two of our angles are congruent to two of the other angles, we know they're similar. And you might be wondering, what about that third angle? But if we think about it, if every triangle adds up to 180, if these two are similar or congruent to those two, we know that third angle will be the same. And that is enough information for us to know that these two triangles are similar. Now keep in mind, similar does not mean they're the same size, but they are proportional. So down here, using side-side-side similarity theorem, which of the following three triangles are similar? So all we have to do is check. And this one kind of helps us out because it color codes it for us, red, green, and blue. But we want to check, are these proportional? So in order for them to be similar, there would have to be a proportion that is consistent throughout. So if we look, we can just start with the first two. So the longest side here, 12, will match with the longest side there, which is 8. So if I do 12 over 8, that would reduce, hopefully you know 4 goes into both of those. It goes in 3 times and 2 times. Okay, now the next one, green, so that'd be 9 over 6. And that would be proportional or reduced to 3 over 2. And the final one, red, 6 over 4. That reduces down to 3 over 2 as well. So since we got all three sides are going to be proportional, we can determine that these two are congruent. So I can go ahead and circle this one. In case we wanted to double check, well, maybe this one also works. So we can look, and the longest side here, 12 and 14. And if we do 12 over 14, so if we want to double check though, as I said, we can do right here, 12 and 14. So if we compare that, 12 over 14, and that one would reduce down to 6 over 7. So now if we compare the next one, we look green, 9 over 10. And 9 over 10, that can't reduce. 6 over 7 and 9 over 10 are not the same. So we know this can't be proportional. It's not similar. And if it's not similar to this one, since those two are similar to each other, it won't be similar to this either. So once again, let's look. We just can compare the sides that are the same. This time they're not color-coded, but here's my trick for you. If we look here, 10 is the longest side. So let's find the longest side of the next one. It has to match with the longest side. That's the only one that would make sense. So we've got 10 and 15. That's going to reduce to 2 over 3. Okay, next, the middle side, so 8. The middle side here is 12, so 8 over 12. That is also 2/3. And finally, 4 over 6, 2/3. So all three of those, and we have our answer. Just to be sure, let's double check that this one doesn't work. So the longest side, 10, goes with longest side, 12. 10 over 12. That reduces to 5 over 6. Our next one, 8 over 10. This would reduce to 4 over 5. So they are not the same, which means this is not similar. So that's by SSS similarity theorem. Now the next one here, side angle side similarity theorem. It says, are these triangles similar? So as we can see, 110 and 110, these two angles are congruent. So if this is proportional, meaning the 6 and the 8 and the 8 and the 10 and 2/3, if those match up, then it would be similar. So we can set up an equation here, a proportion, 6 over 8, and we'll check, does that equal 8 over 10 and 2/3? Now, if you think about it, this one rotates. It'd match up 10 and 2/3 here, the 8. I know these sizes maybe don't make sense. This is 8, and this is 8. That's not drawn to scale. Bear with me. We'll continue. It's fine. So we cross multiply here. We multiply 8 times 8 is 64. Now, 60 times 10 and 2/3. 6 times 10 is 60. And 2/3 of 6 we know is 4, so we'd also get 64. So that tells us that are they similar? Yes. Now our next one, it says we're going to have to draw a triangle. It says the ratio of VW to MN is 6:1. In triangle VWX, angle W is 30. So I'll start with VWX here. VWX, we know this angle is 30 degrees. It tells us VW to MN is 6:1. So let's draw a triangle MNP. And for this, angle N is 30 degrees, so I can put that in. Now, VW to MN, 6:1. So VW is over here, 6. MN is 1. I'm going to put 6x to 1x. We don't know exactly what the side is, but the ratio is 6:1. Now, for the next side, the ratio of WX to NP is 6:1 also. Once again, we don't know what it is. I'm going to put 6y. And this one, I'm going to put 1y. And we can compare those. And we are done because here we have side, angle, side, similarity postulate, or similarity theorem. Okay, our final one on this section, once again, we said if we could have two angles that are congruent, we know they are going to be they're going to be similar. Okay, so if we look here, 2 right angles are already marked. Now, hopefully you remember these 2 angles, they're going to be congruent. That is what we call our vertical angles, okay? And because those are vertical angles, we know they're congruent, which gives us our second congruent angle. So now the triangles are proved to be similar using AA, or our angle-angle similarity postulate, as we talked about here. Okay, the second one here. This one, once again, the right angles we know are the same. Now here, these arrowheads mean they're parallel. We briefly talked about this yesterday's lesson, but this angle and this angle, those are parallel. Think of it as 2 lines cut by a transversal. So right here and here, those would be what we call corresponding angles. And I could mark them congruent because corresponding angles are congruent. All right, our final one now says use properties to show that they're similar. We got our right angles, that's good. Now up here, this angle right here, if we think about it, let me draw. We've got the big triangle. Not a very good triangle. Let me try that again. Okay, so a big triangle here, V, Z, Y, W. Then we also have this small triangle, W, V, X. Okay, and if you look, they both have the same angle here at W. That angle is the same for both. It has to be congruent to itself. That's something we call the reflexive property. If you had me last semester, I know we talked about it. If not, you probably did. But we more often saw that when we had like a triangle like this, and this side in the middle was congruent for both of them by the reflexive property. So that was just some information about similarity in triangles. Now today's assignment is more dealing with our proportions when triangles are similar. So you're going to have some questions like this. So like this is in Delta Math, you're going to go in there, sign in. It says triangle LMN is similar to triangle OPQ. Find the measure of side PQ round your answer to the nearest tenth. Okay, so it's the same as what we've been doing, except now they use words. LMN, so we know that LMN, LM matches up with the OP, so 10 there. So if we would draw this, let me pull up a blank page. Let me close this out so I have some room. All right. So from here, we can set up, we said LMN, so LM, the 47, I'm going to put that over 10 because those two match up. I'm going to set that equal. Now the 35 will go over an X. I don't know what it is. That X is from right here. We don't know what side PQ is or QP, okay, this side. But we know that that has to be, since they're similar, it has to be proportional. We can cross multiply 47x equals, now 35 times 10 will be 350. When we divide this, pull up a calculator. I don't expect you to do it in your head, especially when we're going in the nearest tenth. So 350 divided by 47. And now, here's where we need to be careful. We're rounded in the nearest tenth. That's the first decimal places. So 7.44. Go 2 decimal places, but then the second one is less than 5, so we round down. So x will be 7.4. We round down. If this had been 7.48, we would have rounded up to 7.5. So 7.4, we just type it in, submit. It'll ask you, are you sure? You say yes, and you see we get a check. So if you need any help, please let me know. Hope you guys have a great day. Please go to Delta Math and get that assignment done.